We're in Rosen, section 2.3, discrete mathematics and its applications, and we're going to discuss logic gates or circuit representations for Boolean algebra. Um, we'll talk about logic gates today in this video, and then in a separate video we'll give an example. Here are the logic gates, and we've actually already encountered these if you've seen chapter 1 or studied chapter 1, where we created logic gates for propositional logic. And since that is a Boolean algebra as well, it's natural that we would have logic gates for other Boolean algebras, including the one we're studying now with 0, 1 values, Boolean products, and Boolean sums. And the appearance of these is very similar. We have, for negation, we call it an inverter, and complementation in the case of our Boolean algebra. And in that case, we use a triangle with a small circle at the end of it, where x is the input and the complement of x will be the output. For a Boolean sum, we will use what is called an OR gate, because it is very similar to the disjunction operator in propositional logic. So for the OR gate, we will have however many inputs we need, in this case only 2, and to combine them we will sum all of those inputs together to get the output. And one of the ways I remember that this is the OR gate is that it's kind of curvy, and the O is a very curvy letter, circular letter, and the OR gate has nothing but curves. The AND gate is the basically the Boolean product operator. So however many inputs there are, the output will be the product of all those inputs, or in propositional logic, the conjunction. And that means it's operating like an AND. And notice that this gate looks like a D, and the word AND has a D in it. So that's how I remember that that's the AND gate, or the product gate. And here we have an AND gate with several inputs showing the product. And here we have an OR gate with several inputs showing its product. And we can combine these together to create various circuits to express Boolean functions, or to give us the output of Boolean functions. All right, so here's one example that we want to try to create a circuit that gives us the output for x times y plus the complement of x times y. Well, that means we're going to need two AND gates and inputs for x and y. And these are very similar, the two representations we have here. One, we have the a specific input for each variable twice, and in the first one they are multiplied together. In the second one, we take the complement of one, then multiply it together, and then we sum them using the OR gate. In this case, we only have two inputs, but then we peel their values off. And in the case of the x, we pass it through this inverter before passing it through the same circuitry to get the same output. Okay, so the form of the expression gives us the information we need to write down a circuit that gives us the output. Let's do a couple more examples. All right, here's the three. For A, we have a Boolean product, and then we have, before we do that, we have a Boolean sum to do first because it's in parentheses, and we have an inverter to add in there as well. And here's what that will look like. We pass x and y through a Boolean sum, an OR gate, to get x plus y, pass x through an inverter to get x complement, and then we multiply those together to get the value of the function, or the expression of the function. For the next one, we have x complement times the complement of the sum of y plus c complement. So the first thing we need to do is this uh, sum. And before we do that, we actually have to invert the value of z. And then we can sum y and z. And then we have to take the complement of that whole thing to get the complement of x plus complement of y plus z complement. And then we want to get x complement so that when we multiply them together using this AND gate, we get the expression we're looking for. And then finally, we have in C, we have 3 variables going into an OR gate and 3 variables going into an AND gate after having passed through inverters. Here's my variables going into the OR gate. Here's my inverted variables going into the AND gate, and then I've got to multiply them together to get my final product. Okay. So that's some examples of creating logic circuits using Boolean expressions.